NASA is physically building a massive 8-rotor car-sized drone right now to explore a distant alien moon. Physical assembly of the spacecraft's intricate flight hardware is already underway in cleanrooms. The target for this massive machine is Titan, the largest moon orbiting Saturn. Surviving there means enduring surface temperatures of -290 degrees Fahrenheit, liquid methane rainstorms, and sprawling dunes of organic sand. Chemically speaking, this environment is a deep freeze replica of what early Earth looked like billions of years ago. On Earth, rovers struggle with soft sand. On Titan, these organic dunes stretch for hundreds of miles, creating a landscape that would swallow wheels. To navigate this terrain, NASA is abandoning the ground and taking to the alien sky. This animated diagram illustrates the drop in solar radiation between Earth and Saturn, which renders standard solar panels useless for powering a heavy drone that far from the sun. Without sunlight, the drone requires an internal power source capable of generating sustained thrust. The drone's schematic reveals a glowing cylindrical core, a multi-mission radioisotope thermoelectric generator, which converts heat from decaying plutonium into electricity. During Titan's nights, the drone remains stationary on the surface, using that internal heat to transition its battery to a fully energized charging state. Once daylight breaks, it utilizes this stored power to execute multi-mile hops across the alien terrain. Mastering compact nuclear power is the only way to move past solar limits and make heavy aviation in deep space a reality. But that massive weight raises a question. How do you fly a 1,000-pound drone if there is no air? Titan is not a vacuum. It actually possesses a massive, dense atmosphere. This bar chart shows that Titan's surface air pressure is 1.5 times thicker than what we experience here on Earth. Looking at the second dataset, we see that Titan's gravity registers at barely 14% of Earth's pull. Thick air and low gravity combine to make flying a heavy machine physically easier on Titan than it is on Earth. Pushing against that dense atmosphere requires 40 times less power for a rotorcraft to stay airborne. This environment turns a freezing moon into a highly efficient playground for extraterrestrial aviation. This $3.3 billion mission is focused on a specific scientific goal. The entire mission is structured as a dedicated hunt for the chemical recipe for life. In 2034, the surface mission officially begins when the massive drone finally touches down in the Shangri-La dune fields on Titan. From there, it will execute multiple flights towards its final destination, the Selk impact crater. When a meteor struck this crater, the heat melted the icy crust, creating a temporary lake of liquid water that mixed with complex surface organics. To extract those organics, mechanical drills attached to the drone's landing skids will grind into the alien soil to collect samples. An onboard mass spectrometer will then analyze the chemical makeup to see if building blocks like amino acids and DNA bases are buried in the sand. We are using 2026 aerospace engineering and advanced nuclear power to hunt for our chemical origins. Hit subscribe to stay ahead of the science shaping our future.